Nuestra siguiente ponente es Jasna Malešič. Welcome, Jasna. We're delighted to have you here as well. While you start preparing, I will introduce you to our viewers in Spanish. Jasna es investigadora en la Facultad de Química y Tecnología Química de la Universidad de Ljubljana. Dirige el Departamento de Conservación de la Biblioteca de la Universidad y es autora de diversas publicaciones sobre conservación de material bibliográfico. Hoy viene a presentar y hablar sobre el empleo de Bookkeeper en la deacificación en masa. So you have now 25 minutes for your presentation, and thank you very much.
Thank you very much for your introduction, Sarah. Can you see the whole screen now?
Yes, I can see the full screen. You can start.
Oh, thank you. So, good afternoon, ladies and gentlemen. Well, as already presented, I would like to speak to you or show you some results from the evaluation of Bookkeeper mass deacification, which was based on historical book papers. Well, I come from the Slovenian National and University Library, and among our key missions is also to preserve and enable the use of the national collections of library materials. We store approximately 3 million units of different library materials on various carriers. But still 90% of the collection is paper-based, and actually the most problematic part is of course written or printed on acidic papers. Well, we know that the acidity or the reduction of the paper pH was caused by the changes of paper productions. Well, instead of very high quality linen, hemp, or cotton fibers, then they began to use wood pulps and also alum rosin sizing. Well, alum rosin sizing, as you know, has low pH, inducing acid catalyzed hydrolysis, and the majority of our collection, actually around 80%, is threatened by the acid hydrolysis. Here on this photo, you can see one example, because we know that actually acid hydrolysis leads to total degradation or the brittleness of the paper. Well, the condition in our library was already surveyed in 2006, while it was performed during the 6th framework project Paper Treat, led by Jana Kolar. And at the time, more than 1,000 books were analyzed, and we saw that already at the time we had around 36% of brittle books in the collection. And an estimation was made that actually we will end up with 5% more brittle books every decade. Here on this figure, we can see the percentage of brittle paper against the date of publishing. And for Slovenia, we see that actually it started the era of acid paper started in 1850s and it ended at 1980s. So in order to plan a preservation strategy, also some research was made also already during that program. And we know that actually we have two options. One is to deacidify the books, and another one is to store them under cooler or cold conditions. Well, we can see here the figure, and on this axis we have factor of stabilization plotted against preservation strategy. So commercially available Bookkeeper deacidification was used at the time on some test papers. And we can see that while the Bookkeeper performed 3.5 better in comparison to untreated paper samples, that storage at 15 degrees Celsius actually changes the factor of stabilization by a factor of 2. If we store the books at 5 degrees Celsius, they will be 8 times more stable. But if we combine deacidification with storage at lower temperature, the effect is even greater. Well, another thing was developed by my colleagues. Actually, it is a collection demography app, and you have a link here. Well, this one supports preventive conservation decisions based on environmental inputs, meaning temperature and relative humidity. And it calculates the predicted remaining useful life of paper. And we can use it also for to calculate the effect of long-term deacidification on various collections. So we can see here the application of this app. Well, I have entered the conditions in our library, so 18 degrees Celsius and 50% relative humidity. And I have inserted some values. So mass deacidification costs approximately 10 euros per unit. And we can give 50,000 euros annually on deacidification and on our library collection. And we can see here the plot, actually the applications. The application draws a plot, and we can see here fitness of use, meaning if it's still in usable condition, the books, against the time. And we can see that for deacidified collection, almost all of them will be still in usable condition, while the untreated books will almost all will be in unusable condition. But of course, this depends on the deacidification agents, on the type of deacidification, and we will see further something about that. Well, at the time that we were selecting the process for our library, I could only rely on the data that was published, and actually they claimed that Bookkeeper process is effective, and also Library of Congress, as the world's biggest library, used it. And also they claimed that the effect of Bookkeeper process is great in terms of stability of paper, that the paper treated with the process is at least 3 times more stable. Well, because I was in charge of preservation in our library, I knew that every cure or every, if you want, conservation treatment also has some side effect, and we have to be aware of that. So, and this was also looked into, and different processes available at the time were checked out. And we saw that actually, besides the deposit of magnesium oxide on the surface of the paper, actually Bookkeeper induces very little side effects, such as stem bleedings and deformation of the binding and so on. And therefore, we have decided and introduced mass deacidification program. So we selected only because of the deposit of magnesium oxide on the surface of the paper, we decided to deacidify only the books that are not used by our end users. And these are archival copies, which are stored in the library for our future generations. So we sent each year, we selected from 500 to 2 tons of books each year and send it for mass deacidification to the Netherlands. So, of course, when we got the shipments back, we saw, we always assessed the condition of the books. And of course, there was some deposit of magnesium oxide, but there were no other side effects. Except for some mechanical damage, but mostly it was caused on soft bindings, which were already quite degraded on the spine. Well, we also perform some chemical analysis, but this on original documents, of course, can only be performed on test papers. And we inserted this into 10% of the shipment and measured the pH value, the alkaline reserve, and also the uniformity of the acidification. But actually, I was a bit cautious because no recent investigation have been carried out at the time on Bookkeeper deacidification treatment. And actually, in the literature, there were quite different results of efficiency. Some claimed that it has from 3 to 5 times that is more effective. Others claimed that Bookkeeper is not effective. So, and the main drawback actually of this evaluation was that the tests were carried out on a limited number, only on model paper samples. So this is the thing that I also wanted to claim before. Well, it is important that you have representative material in order to test some deacidification treatment. So for this study, we used 2 sets of disposable books. So we selected some books in the library that were not usable anymore. So, and these were published from 1887 and until 1980s, and we could destructively analyze. So these were just real books from the library. And we sent them together with the books from the library intended for mass deacidification. And this was performed 2 times. And also the books were deacidified in 2 different batches. So then we have evaluated the treatment efficiency. We know that usually the deacidification is evaluated by the measurements of pH value of the treatment, and then the alkaline reserve, which is deposited in the paper structure. But also we have measured the DP values of the papers before and after accelerated degradation. So our untreated papers had pH values from 4.4 to the neutral value that was measured against according to bulk extraction standard. And after deacidification, the pH values were okay. So they were higher than those of untreated papers and reached up to 8.6. Well, according to the ISO standard, which prescribes the pH values of the test papers, of course, not the originals, because it's better not to measure them. And they claim that it has to be higher than 6.5. And that was okay. So then we measured alkaline reserve. You know that one part during the deacidification process, one part of alkali is used up for neutralization. And the other part that still stays into the paper fibers, they form alkaline reserve. Well, we want this alkaline reserve because it protects our paper against further degradations and against the gases that form that came into the storage areas. So we requested, based on Library of Congress recommendations, around 1% of calcium carbonate. That doesn't mean that during the treatment we have calcium carbonate inside the paper. It is just calculated. It is expressed in percentage of calcium carbonate. So ISO standard prescribes different value for approximately 0.6. And we can see here for our 2 batches, the values of alkaline reserve. So A1 to 11 is first batch, and B1 to B13 is second batch. And we can see that almost all samples, or very little samples, actually fit to the recommendation. So the alkaline reserve was a little bit too low. What is also important is that the books are homogeneously deacidified, and therefore we have measured the distribution of alkaline reserve over the cross-section of the text block. So we measured alkaline reserve at the beginning, in the middle, and on the end of the book block. If the book block was thick, if it was thin, we only measured 2 times. And we prescribed that it should not vary more than 20%. Well, this applied to half of the samples, but some books had very large inhomogeneity across the book block, as we can see here on this A2 sample. And then we have measured the degradation rate constants. What are degradation rate constants? Well, we calculated them from the DPs during artificial degradation of papers, meaning that the higher the degradation rate constants, the higher the degradation, the bigger the degradation. So usually the degradation rates slow down with increasing pH value of the papers. And this was true if you look here at this figure for our untreated paper samples. So the higher the pH, the lower the degradation. And we would assume that after deacidification, when the pH value is increased, that our degradation will be slower. But that was not the fact in our paper samples. And we were, of course, asking why. So also we have calculated the efficiency factor, which estimates the prolongation of paper lifetime after deacidification treatment relative to non-treated samples. So meaning, I said before that they claimed that the efficiency factor of Bookkeeper deacidification process is from 3 to 5 times. But as we can see here from these measurements, only few samples complied to this. Otherwise, in other cases, the efficiency factor was 1, meaning it was the same, the degradation was the same, either with untreated and with treated paper samples. So we were asking, of course, why? Why is this happening? The pH value is okay. The alkaline reserves, well, not okay for all the samples, but in some samples it was okay. Why isn't this deacidification okay? So that's why we have performed same EDS analysis to see the distribution of magnesium ions first on the surface of the papers, and we saw that they are not uniformly distributed across the paper surface. And then we have made same EDS cross sections. Well, here first we can see the untreated papers and then deacidified. And we can see actually here these light dots that the magnesium particles are only on the surface of the paper, but that is of course not good. So deacidified was only the surface of the paper, and because they didn't enter, they didn't go into the paper structure, most of the paper was not deacidified. And you would assume that after artificial aging at 65% relative humidity, this particle would go inside the paper, but that was not the case. Still, the particles remained on the paper surface, meaning that even after lots of time, they won't enter, in most cases, the papers, and they will not be deacidified. And this can be the explanation of the limited effectiveness of the treatment, meaning where you have some dispersions, they might not induce any changes into the paper structures if they don't enter the paper. So if we have non-aqueous dispersions of alkaline particles, such as magnesium oxide, These methods for determining pH and alkaline reserve cannot be used to evaluate the treatment efficiency, because we know that we measure the pH in the water dispersions or the water solution. So this is some kind of average pH. It is not the pH within the paper structure. And also alkaline reserve, as we see, was not distributed. So it is very important, besides pH value and besides alkaline reserve, that actually the particles, the alkaline particles, are homogeneously distributed across the paper. So our efficiency factors, which were determined after accelerated thermal degradation, showed that our treatment with Bookkeeper is only very limitedly effective for the majority of our paper samples. So if you need some more additional information, you can read the paper that was published in Cellulose last year. You can also write me on my email. Well, I would like to say something about my previous intervention. Well, we all know that every treatment has some side effects, but actually we have to be careful, and we as a chemist have to inform the restorers about its side effects, because we don't want to cause any harm to the paper objects. So thank you very much for your attention, and I'm here, of course, open for some questions.
Thank you so much, Jasna, for sharing your research through this splendid presentation. It's quite interesting how we can see that Bookkeeper is in reality a superficial treatment, even though we can see a pH values going up or going high. There's no really correlation between the degradation of paper. And also, I found interesting how we can get the best results combining cold storage with deacidification for our library materials. Well, we really appreciate that you took the time today to be here, and I believe we'll still have time for some questions. And Emma, no sé si quieres comentar algo más.
Sí.
Estaba mirando desde ahí.
Mientras Sara mira las preguntas, Jasna, tienes habilitado el traductor, ¿no? Sí. Sí. Bueno, te quería dar las gracias sobre todo por presentar el proyecto SINJAP, que se conoce poco en España y dio lugar a muchísimas publicaciones y estudios. Y sobre todo el problema que tiene la desacidificación en masa, que es tomar una política de preservación sabiendo las consecuencias que en algunos momentos o en algunos puntuales podrían tener. Por eso hay unos productos comerciales, unos niveles de calidad y que, bueno, pues no es fácil elegir la política de preservación. Tú has contado muy bien cómo al final tienes que elegir para conservar una colección con un periodo de tiempo muy establecido, donde sabes las alteraciones que se van a producir. Y nada, solo era eso, que gracias por traer a España esos estudios y sobre todo también por poner la variable del frío, que para nosotros no era tan conocida, y cómo podemos además introducir, modificar el pH, el frío, y cómo podemos jugar con ello de cara a la preservación, que es otra parte diferente de la restauración. Entonces te agradezco inmensamente que hayas compartido con nosotros los conocimientos. Muchísimas gracias, Jasna.
Thank you very much. I'm happy that you invited me here. So thank you to the organizers. I think you are doing an important work.